And now, on with the show.
The Midwest has the potential to be one of the biggest generators of green energy through one element: wind. In fact, the state of Iowa alone has almost more total potential wind generation than the entire eastern seaboard combined. That is some serious power. And it's not just wind. Rural areas have huge potential for solar and hydro-generated power as well. The upper Midwest could be one of the most energy-rich places in the whole country in the next 50 years. But getting that power to the places on the coast that need it is a huge problem. Our infrastructure to move power is old and starting to come apart. These lines we use in towers are also old tech, which has since been vastly improved on. Ames National Laboratory, based in Iowa, is working on technology that can not only improve the efficiency of these power lines, but also last much longer.
I'm Ivor Anderson. I am senior metallurgist here at Ames Laboratory. So the United States has a problem that it's been ignoring for about 40 years. So at this point, transmission lines, especially the high voltage ones that you see overhead, those transmission lines, most of them are about 70, at least 50 years old, maybe some of them 70 years old. From a metallurgical standpoint, many of these cables are actually reaching a fatigue limit. And so many of the times those cables have been stretched to their, what we will call an elastic limit, and they start to sag. They're starting to actually permanently deform.
My name is Dustin Heckman. I've been part of the power group for approximately 7 years now. I'm a fourth year PhD candidate now. And I've been studying the aluminum calcium conductor composite materials for approximately 7 years. I started in my undergrad, which was also at Iowa State. There's an ever-increasing demand for power. With that increasing demand, there's going to be increased electrical loading on our power lines. In order to stabilize the grid, we need to introduce high voltage direct current and high voltage alternating current to have this sort of smart grid technology basically transmit power from coast to coast, depending on the geographical region of, say, wind on the east coast or the west coast and sun in the south. We'll be able to pool those resources into one grid and stabilize the grid that way, basically.
A new kind of cable is being developed at Ames Lab using a surprising ingredient: calcium. Adding calcium to the alloy used in power cables not only makes the cable stronger, but stronger as power is run through it. There's an added bonus as well.
So calcium is special because it's very abundant in the Earth's crust. It's the fifth most abundant element in the Earth's crust. It has high conductivity, similar to that of aluminum. It has the same crystal structure at room temperature, which is the face-centered cubic crystal structure, which means that it will deform similarly to aluminum when you make a metal-metal composite through heavy deformation.
Thinking about how calcium deforms under pressure and heat is a relatively small change in technology. It's not a space elevator or a cure-all for climate change. But when this technology is multiplied over hundreds and hundreds of miles, it makes a big difference.
Yeah, this is a heart and soul project for me. Yes, it is. And it does have to do with taking advantage of, for instance, wind power and certainly solar power. The statistics are, I think solar power is probably about 1/5 of the cost of coal-fired power. And wind power is probably about 1/3 of the cost, between 1/2 and 1/3 of the cost. So there's a lot of incentive, and things are moving in the right direction right now. Because I now have 2 grandchildren, not just one, and definitely at their ages, 4 and 4 months, they'll see what the consequences are of what we do now. So there is no way to overemphasize the urgency of what we do now.